Hi, welcome to lesson 6.6, surface area of cones, spheres, and pyramids. So, oops. Okay. So we talked about volume of surface area cones, or volume of cones, spheres, and pyramids the other day. So today we're just going to move on to surface area. So remember to use your formula sheet. That's where I'm getting all these equations from. So we're just going to jump right in and try some of these surface area problems for a pyramid, a cone, and a sphere. So if you take a look on your formula sheet, you'll see that for a pyramid, the surface area is 2 base times slant height plus the base squared. So if we look at this pyramid, we have the base, right, is 24. They actually gave us the slant height here, so that's 16. If they hadn't, right, we could just use our Pythagorean theorem to figure it out. But in this case we have it, so we can just go right ahead and plug into our formula. Okay, and we get 1,344 meters squared. Remember, surface area is always meters squared. If we try this for our cone, surface area for the cone, the formula is pi r times the slant height plus pi r squared. So if we take a look here, they didn't give us a radius, they gave us a diameter, so we could divide that by 2 and we get 4.8 centimeters. And then they gave us the height here. So this is the height, but we need S. So in order to figure out S, we're going to have to do the Pythagorean theorem. So I'm just going to quickly draw myself a little triangle here with my information. So we know that this is 4.8, and we know the height is 12.8. We want to find that slant height here. So actually, I should probably put S. S is the hypotenuse. So S squared is going to equal 12 squared plus 4.8 squared. Oops, squared. So if we square both of those and add them together, you get 186.66. Square root both sides, and we get 13.7 centimeters. Okay, is our slant height. Okay, so now we have all the information we need. We can just plug this in. So pi times the radius times the slant height plus pi times the radius squared. Okay, so again, whenever we have like pi like this, we can keep things in terms of pi. So we could do 4.8 times 3.7. That's 23.07, and then pi plus 4.8 squared is 67.76 pi. Add those together, we get 88.8 pi. Multiply that by pi, and we get 278.97 centimeters squared. Okay, and then part C, this is supposed to be a sphere. It should be 3D. It just doesn't really look like it. So surface area of a sphere is just 4 pi r squared. So in this case, they gave us the diameter, so we need to divide by 2. We get 3.5. So 3.5 squared, we can plug that right in. This is a nice easy one, just multiply everything, and you get 153.93 centimeters squared. Okay, so there's our formulas for each of those shapes. And now we're going to move on and we're going to try some composite figures with our surface area. Okay, so we're going to put together all of our shapes. So we take a look at this one here. We have a cylinder in the middle. And then on the ends, we have what looks like kind of 2 half spheres. So if we were to take out the cylinder and put those ends together, we'd end up with one whole sphere. So in reality, this composite figure is actually a sphere and a cylinder. But the cylinder, because we're talking about surface area, the top, so this part, the top and the bottom of our cylinder, it wouldn't count towards our surface area because it's not on the surface. Think about if we wrapped this in wrapping paper. you wouldn't wrap anything on the inside. So we're going to have to take that into account when we're actually figuring out our surface area. We're going to want to not include the parts that are inside here. So our total surface area would be the surface area of our sphere plus the surface area of our cylinder. Okay, so we know that the surface area of a sphere is 4 pi r squared. And then the surface area of our cylinder is 2 pi r h plus pi, oh no, that's it. Yeah, no, plus pi r squared. The pi r squared represents our circles, right? Just making sure I got my formula right. Two pi r squared. There we go. That's what I was missing. Okay, so this part right here, this 2 pi r squared, that represents the cylinder, or the top and the bottom of the cylinder. So we said that that part, it's not going to count towards our surface area because it's on the inside. So all we need is this lateral face, is what we call it, like the around part of our cylinder. So this part we're actually going to eliminate from our equation, those two circles on the top and the bottom. So once we have that, we can start plugging in. So for our sphere, we need the radius. Well, they gave us the diameter, so divide by 2 and we just get 1 meter. So this is 1 plus 2 pi. And then the radius for our cylinder and our sphere are the same, so it's just 1. And then the height is 3.4. Okay. So again, we can just do this in terms of pi. So this is 4 pi plus 6.8 pi. And this is 10.8 pi. If we multiply that, we get 33.9 meters squared. Therefore, surface area of the figure is 33.9 meters squared. Okay. So if we try another one here, so in this one we have another cylinder, and then on top of it we have a cone. So we know we're going to have to find our total surface area, and it's going to be our surface area of the cone plus the surface area of the cylinder. Okay, so surface area of a cone is normally pi r squared plus pi rs, right? So the pi r squared represents the circle on top. The pi rs represents like the actual kind of triangle-y part that goes around. Now if we look at our picture here, again, think of the wrapping paper idea. This little circle on the cone here, it wouldn't be counted because it's sitting on top of the sphere, so we wouldn't wrap that part. So again, that part is represented by this pi r squared, so we don't need that in our equation. Okay, so then we need the surface area of our cylinder, which is 2 pi r squared plus 2 pi r h. Right, so that's our cylinder. But again, for our cylinder, if we take a look at cone part that's sitting on top, we wouldn't wrap that little circle that's the top of the cone. So we're going to have to subtract that pi r squared from the cone. Right, we need to get rid of that little circle because it's on top and we need to cut it out. Okay, so now let's take a look. What pieces of information are we missing? So for our cone, we have the pi, the radius, well they gave us the diameter here, so we could divide that by 2 and we get 1.7 centimeters. And we need the slant height, which they gave us, right? This 8.6, that's our slant height for the cone. So we've got that. Okay, so this is for my cone. And then for my cylinder, if I take a look here, we've got 2 pi. Radius we need, so we can divide this by 2 and we get 5.6 squared plus 2 pi and then radius again. And the height they gave us is 9.3, right? This is our height. And we want to subtract pi r squared for the cone. So our radius for the cone is 1.7. Okay, so let's try this here. So again, we're just going to do in terms of pi. So we've got 14.62 pi for the cone. And then for the cylinder, we've got 62.76 or 72 pi plus 104.16 pi minus 1.7 pi. All right, so now I'm going to do 14.62 plus 62.72 plus 104.16 minus 1.7, and that gives me 179.8 pi. And then I'm going to multiply that whole thing by pi, and we get 564.86, which somehow is like one number off of what I actually got. So I think I put a number in my calculator wrong. Let me just double check here. So we've got 1.7, 8.6, 5.6, 5.6, 9.3, 1.7. Okay, let me double check in my calculator just to make sure that I didn't type in anything wrong. 62.67, yep. 1.6 times 9.3, 104.16. Oh, I know. I forgot to square this one. That's where I went wrong. Be careful. Make sure you put in your squareds. Don't make my mistake. So this should be 2.89. There we go. Now it'll make sense. Okay, so let's fix this answer here. Okay, so 14.62 plus 62.72 plus 104.16 minus 2.89. 178.61 pi. 561.12. That is the right answer. Whew. Centimeters squared. So therefore, surface area of figure is 561.12 centimeters squared. Okay. All right, and last question here. So we have the frustum of a cone is the part that remains after the top portion has been removed by making a cut parallel to the base. So we want to calculate the area of this frustum to the nearest square meter. So basically, from the picture, they want us to calculate the surface area of the blue part. So in order to do this, we're going to have to figure out surface area of the entire figure, surface area of the little part that they cut off, subtract them. So we want the surface area of the frustum is going to be my surface area of the big cone minus the surface area of the small cone. Okay, so for the big cone, we have pi r s plus pi r squared, right? That's for our big, minus the surface area for our small cone. Okay, so now we just need to check what do we need. We have radius, right? This is our radius for the small. We have radius for the big. Slant heights. Okay, so they gave us actual heights. So I'm going to need to figure out some slant heights for the small and the big. So I'm just going to call this one S, and I'm going to call this one R. So I want slant height for my small one, right? If we do that, draw myself a quick picture. So I'm looking for S, height is 2, and radius is 1. So we've got 2 squared plus 1 squared is 5 squared. Square root of those is 2.24 meters. Okay, and then for my other one, I've got radius here. I'm just going to call this R. And then my height, be careful, they gave you this 6 up until here, but then we need to add another 2, so it's actually 8. So then for this one, R squared equals 8 squared plus 4 squared. So 64 plus 16 is 80. Square root of 80 is 8.94 meters. Okay, so now I have all the information I need and I can plug it into my equation here. So I've got pi times the radius of the big one is 4 times the slant height of the big one, 8.94, plus the radius is 4 squared. Alright, and then we've got for our small, radius is 1, slant height is 2.24, radius is 1. Okay. Alright, so for my big, I got 4 times 8.94 is 35.78 pi plus 16 pi, right? Minus 2.24 pi plus just pi. So then this is 51.78 pi minus 3.24 pi. And we get 48.54 pi times pi, 152.49 meters squared, but they wanted this to the nearest square meter, so I would call this 152 meters squared. So then, therefore, surface area of frustum is 152 meters squared. Okay, so that's the end of our surface area of all of these different shapes. So give your homework a try, really practice these composite figures.